Here is my note card so far. You guys have seen this. I have room still for Module 8, Module 9, and Module 11. Remember to think about budgeting space for Module 11 and how much space you would like to budget. So if you're going to put an entire unit circle on there, you need to maybe budget a little bit more. Remember that you could also put the first quadrant on there and then think about the reflection. So it's up to you what you would like to have. Remember, you can write on the front and the back. I'm not going to continue going with my note card, so this is as far as I'm going to go. But these are just some ideas that I have that I would put on mine. Again, they don't have to be the same that you put on yours. But these are just some things that I might put on mine if I were taking the test. If you go back and watch the video later, you could pause it right here so you could spend some more time with the note card. I'm going to take it off the screen. But again, it's in the video. Feel free to go back to it, pause it, and check it out. Module 8 was our module on logarithms. So number 1, we want to rewrite in logarithmic form. So we need a log if we're writing it in logarithmic form. What's my base? 3 of equals my exponent 4. So there are some that are just that easy that ask you to switch the format back and forth. So think about where your numbers went. So 3 stayed my base. 81 is the number I was trying to work my way up to. And then what degree do I need to get there? I need the 4. So if it helps, you can color code a little bit there too to remind yourself where everything went into the other format. And again, you need to be able to move this way, but also back the other direction too. So truly, one example on your note card, if you think you might struggle with that, should be enough, because this one is going to be the flip. So this is going to be 5 to what power equals 1 over 25. Okay? So again, if you're putting one of these examples on there, I don't think you need both 1 and 2, but maybe number 1. Remember, you can put examples on there. You can put definitions, theorems, whatever you'd like to put on there that you think is going to help yourself, little friendly reminders, other things. Let's put phones and other stuff away so we can make sure that we're reviewing and getting ready. Thanks. All right, so remember, this problem is really saying 6 to what power equals 0? 6 to the 0 power would be 1. Does anything give you 0? This would be a no solution. There's nothing that would get you to 0. So anything to the 0 power is going to give me 1, except 0 to the 0, which is undefined. So this would be a no solution sort of situation. This one is saying 7 to what power is 49? 2. 12 to what power is 12? 1. Okay, so those should be fairly quick. Also remember that you have use of your calculator, so you should be able to use your calculator to kind of peek and see like what the answers are that way as well. All right, let's continue on. Ooh, this one's not very long of a review. All right. Let's look at 3a. If we have a variable that's up in the exponent spot, how can I get it to come down? What do I need to do to each side? Multiplying isn't going to help us. So taking the logarithm is, though. So I'm going to take the logarithm of each side. So our strategy for problems like this is to take the log of each side, which at first glance looks like, well, you just made it much worse. You're not wrong. It does look that way. But remember what you can do. When you take the log of something, you can move the exponent out front. And so the nice thing about that is now we have everything kind of lined up horizontally here. Do you notice how I didn't write in my bases? What does that mean about my base? They're 10. Yeah. And I always pick 10 because I can use the 10 on, or the log base 10 button right on my calculator, and it makes my life easier. Okay, I've got 3x, and I'm going to divide away this log to the base 10 of 5. So on the left, all I have left is 3x. On the right, I have whatever this number is. So on my calculator, this is easy to type in. You're just going to hit log, nope, not ln, log of 45, close it. Hey, make sure that you're reviewing with us. Divided by log 5. And make sure you close your parentheses appropriately too. Did we all get 2.365? Okay. All right, so this is 3x on the left, this canceled, equals, we just calculated that. Now what do I do to finish solving? Divide by 3. X equals 0.788. And again, you can always plug it back in to double check. I don't always do that for homeworks, but on like a test or quiz, I definitely double check, and the exam is worth even more. So I want to go back for 1 second before I do the last problem to my note card. I'm going to put my note card back under. I want you to notice this one down here because we didn't have one of these on the review, but there could be one on the exam. Do you remember that we did exponential growth and decay questions yesterday, like we did some story problems, right, with populations, with money, other stuff? You could also get one with money that's a continuously compounded problem, and that's when you use your other equation, which is PERT. So I just want to remind you of that equation as well, because that could also be on the exam. Sorry, I was thinking about that in the back of my mind, and I wanted to pivot back to this for just a second and remind you that that formula could be there. So make sure you know that one too. And the key words are continuously compounded. Like, you need those two words, and if they exist in the story problem, then this is the formula. Okay? All right. What?
For the P, it's like the initial, right? The initial
Yes.
like,
Oh, sorry. P is the initial. Yep, P is the initial. E is our number friend E. R is the rate. You've got to switch percent to decimal, moving to the left 2 spots. And then T is time. Yep. All right. Got a good sneeze in the video. That's, you know, never go wrong. All right. We have multiple logarithms, and that makes it really problematic for me to try to solve this. One of our properties that we had is if you have 2 logarithms and they have the same base and you're trying to deal with them, if they're being added, you can take and multiply those 2 pieces together. And again, the reason this works is because of our exponent properties, because remember, logarithms are exponents. So x times x is x squared. X times 2 is 2x. Equals, and there's a 3 over on that other side. So again, if you have the same base, you can condense. Remember, we were condensing and expanding. You can condense into a single logarithm with multiplication if they're being added together. If they were being subtracted, you would condense with division. So all those rules should be back in your Chapter 8 notes packet. Do you remember how to get rid of a logarithm? We're going to raise each side up as an exponent. So these are kind of like the raise the roof problem. So you're going to raise each side up as an exponent. And remember, when this and this match, it cancels. So now I just have x squared plus 2x equals, what do we know 2 cubed is? 8. Yeah, so if the base had been 4, I would have raised each side and had 4 down below. Yep. So that would be a consistent thing. I'm going to subtract over my 8 so I can finish solving. So I have x squared plus 2x minus 8 equals 0. Remember, whenever you have something quadratic, your strategy is to always get everything to the same side, and then you can factor and solve. You could solve graphically. You could solve with a quadratic formula. Like, we have lots of options from here. You know I'm going to factor and solve, though, I think at this point. I know x times x is x squared. What multiplies to negative 8 but adds or subtracts to 2? 4 and 2. So if I do 4 minus 2, I get 2. If I do 4 times negative 2, I get negative 8. What would make this parenthesis 0 if x were? What would make this parenthesis 0 if x were 2? Okay, now, these can have extraneous roots, so we need to be careful. First of all, think about negative 4. Can I ever take the logarithm of a negative number? No. So there's no way that negative 4 can work. That makes 0 sense. Then we can try plugging this one back in. Remember, if you have new software, and I don't know if this calculator does. Oh, it sure does. Okay. If it doesn't, you can use your change of base formula. If you don't remember the change of base formula, you can ask me and we'll talk about that. So I'm going to plug in the 2 in place of x. Log base 2 again. And then this is 2 plus 2, which is going to give me 4. And it gives me 3, which is what it should be equal to. So this one worked, this one did not. But again, remember with a multiple choice test, you're probably going to have a distractor answer. Like, one answer will probably be 2, another one will be negative 4, and then another answer will be 2 and negative 4, right? So you're going to have to figure out which one it is.
Also, can I see your calculator again? Because I swear I entered the same thing and I didn't get 3.
Yep.
Oh, I forgot to add the plus.
Pluses matter, yeah. Okay, so I'm going to give you a worksheet today. We're going to come back and do this topic one more time on Monday.